Welcome to video series on the chapter periodic table of an element. In this video series, we have first video on Dobereiner's law of triad. We have first video on Dobereiner's law of triad. Triad means a group of three elements. Triad means group of three elements. So, what this Dobereiner's law of triad wants to say? So, we have chemically similar elements, that means elements which have same chemical property, when arranged in increasing order of its atomic mass in a group of three. So I have chemically similar element arranged in increasing order of its atomic mass, which constitutes a triad. Then the atomic mass of the middle element, is approximately arithmetic mean of atomic masses of remaining two elements. So I have three elements which are chemically similar, arranged in increasing order of its atomic masses, which makes a one triad. In that triad, the atomic mass of middle element is approximately arithmetic mean of the atomic masses of remaining two elements. So let me have an example to illustrate this. I have first triad where I have three elements: lithium, sodium, potassium. Now, what kind of similar property I can able to interpret here? The very first property I can say, all these three elements are metal. All these three elements are soft metal. Okay. Second, these elements are monovalent. These elements are monovalent. That means the combining capacity is 1. So let me have lithium, sodium, potassium. These three elements I am combining with chlorine. So I get a compound lithium chloride, I get a compound sodium chloride, I get a compound potassium chloride. So to balance this, I'll multiply here by 2 and here also by 2, here 2 and here 2. So in potassium also I'll multiply by 2. Now here you observe that each of this atom combines with one chlorine. So I can say they are monovalent in nature. And third important property, this element on reaction with water forms corresponding alkali and evolves hydrogen gas. So let me have lithium react with water in order to give me lithium hydroxide and evolves hydrogen. So this I multiply by 2, water also multiplied by 2, and lithium hydroxide also gets multiplied by 2 in order to balance the equation. Same way I can write down for sodium. Sodium also reacts with water in order to give sodium hydroxide plus evolves hydrogen gas, and potassium also does the same thing. So I will get potassium hydroxide plus hydrogen. So I have three elements: lithium, sodium, potassium, possessing similar chemical property. That means they are soft metal, they are monovalent, they react with water so as to form corresponding alkali and evolve hydrogen. So the first condition is satisfied. Second, I arrange them in increasing order of its atomic masses. Then I observe the atomic mass of first element that is lithium 7 plus atomic mass of last element 39. So 7 plus 39 divided by 2, that is 23, which is the atomic mass of sodium. So this is first triad which I have. Now let us focus on another example to understand this triad. So I have another element. I have triad 2 where I have calcium, strontium, barium. Now, what are the properties we can look forward for this element? The very first property, all these elements are metal. Second property, they are bivalent. So once again, I do react this compound with chlorine. So I get a compound like calcium chloride, strontium chloride, and barium chloride. As you observe, each atom combines with 2 chlorine. So the valency is 2. So I call this as an bivalent elements. These are bivalent. Third property, they react with water to form a basic oxide, or they form an oxide which is basic in nature. So we may have a reaction with oxygen can be taken here. Let me have calcium combines with oxygen in order to give me calcium oxide. Okay, so to balance this I'll multiply by 2. I have strontium combines with oxygen in order to give me strontium oxide. Okay, here also I'll multiply by 2. And barium combines with oxygen in order to give me barium oxide. Now these oxides are basically basic in nature. They are basic in nature, or I can use typical word as an alkaline in nature. Okay, so these are generally found to be basic in nature, we can say. Okay, so this is similarity in the property. Now look out for the atomic masses. Calcium has got atomic mass 40, barium has got atomic mass 137. So if I add 40 plus 137, so I'll be getting 177, and that I divide by 2, I'll get 88.5. Roughly, I'm getting this as an 87.6, which is near about, we can say. Okay, so this is about the second triad which we have. Now, the third example, which you can take it for the third triad, that is chlorine, bromine, and iodine. These are the halogens actually. So the very first property which you look forward, that they are non-metal. They are non-metal. Second property which I can look forward, that they react with metal in order to form corresponding salt, and they are monovalent. So I can say here they are monovalent in nature. Let us take a simple metal like sodium. I react with chlorine. So I'll get a compound sodium chloride. Sodium, I react with bromine. So I got a compound sodium bromide. Okay, and sodium, I react with iodine. I got a compound that is sodium iodide. Basically all these are salt. Sodium chloride, sodium bromide, and sodium iodide. Now here we observe that they combine with only one metal, that is monovalent. So they combine with one metal, so they are generally considered as a monovalent in nature. So this indicates they are monovalent. Third important property which halogen exhibits, they react with water and forms corresponding acid. So I have chlorine reacts with water in order to give me HCl, and HOCl, it's called as hypochlorous acid. Then I have another compound like bromine, Br2, reacts with water in order to give me HBr, hydrobromic acid, and HOBr, that's hypobromous acid, and iodine combines with water in order to give me Hi plus HOI, hypoiodous acid. Now, when you look all these acids, so generally this hypochlorous, hypobromous, and hypoiodous acid, they are unstable and finally decompose to give you hydrochloric, hydrobromic, or hydroiodic acid. Now, let us look out the masses. Chlorine 35.5, iodine 127. So when I divide that by 2, adding 35.5 plus 127, when I divide by 2, I am getting 81.25, which is roughly atomic mass of bromine as an 80. So here we try to figure out that approximately masses are equal. Now what kind of advantage we can get from this classification? See, Dobereiner's law of triad is considered as the first ever classification, that is, attempt was made to classify the element on the basis of properties. So here, Dobereiner was first person to successfully recognize, I cannot use the word successfully, but some way he was able to find out a relationship between the properties of an element with their masses. So here I am correlating the masses and the property. Now what limitations this classification suffers? Now see, when he proposed a classification at that time, roughly 54 elements were there. So we cannot able to classify all the 53 elements in a group of 3 or as a group of triad, we can say. So this was the very first limitation. All the elements cannot be successfully classified into a group of 3. Now, as we have mentioned in our statement, chemically similar element, they should form a triad. But here is one example where I have 3 different elements, carbon, nitrogen, and oxygen, which do not possess any similar property except they are non-metal. They do not possess any similar property except they are non-metal. They form a triad. Now let me have carbon atomic weight 12, oxygen atomic weight 16. So 12 plus 16, 28, and 28 divided by 2, I'll get 14, which is an atomic mass of nitrogen. But there is no kind of similarity we can exhibit between these 3 elements. Now let me have carbon, I combine with hydrogen, I get a compound that is methane. Okay. Then nitrogen, I combine with hydrogen in order to give me ammonia, and oxygen combines with hydrogen in order to give me water. So as for this particular, I can say there is a difference in property. How I can prove this particular? See, by looking at formation of methane, I can say carbon is tetravalent, nitrogen is trivalent, and oxygen is divalent or bivalent in nature. So there is no kind of similarity we can show between carbon, nitrogen, oxygen except they are the non-metallic element, but still it constitutes a triad. Hope you must have understood this particular classification of element. In the next video, we further study about another type of classification. Thank you for watching.